Hello everyone, my name is Taran Gupta Akirala, and today I'm going to discuss with you about an innovative project called Pattern Matcher. This project is done as a part of pattern recognition course offered at University of Florida EEL 6 year 25. Coming to the introduction and main objective of this project, object detection is a very real-time problem, and due to the current recent advancements in the area of deep learning, we have seen a very huge rise in the prediction accuracy. Object detection classification from out of VIT predefined object classes in the given set of images using deep learning methods with bounding boxes is performed in this project. I have used around 210,000 images in the dataset, which are split into training and testing datasets, and the program output is validated using the MS COCO evaluation program and validation dataset. There are several applications for this project. Some to mention a few: object recognition is performed in text, image, and audio and videos. Facial recognition software uses object recognition. We can also use this in pedestrian detection, which can help traffic signals change accordingly to pedestrians. Optical character recognition, scene understanding, and assistance to disabled, to mention a few more, and there are many other applications. Uh, Let me describe how this algorithm works. Regional proposal networks takes an image of any size as input and outputs a set of rectangular object proposals, each with an objectness score. We don't need any external process for region proposals. MCG introduces a fast algorithm for computing multi-scale hierarchical segmentations, building an efficient graph-based image segmentation. Segments are matched based on edge strength, and resulting object hypotheses are ranked using cues such as size, locations, shape, and edge strength. This gives category independent object proposals. So assume that you have an image of a chair. So the image from the image of the chair, the computer extracts two kinds of outputs. One which only detects the counters. So the chair will have four legs, and then one rectangular box on the top and stuff like that. The other part of the algorithm decodes, increases the contrast and brightness of the image, and then it tries to understand color and depth perception of the chair. So combining once the computer has these two inputs, it combines them, it merges them, and overlaps the contours with the color depth image perception. And overlaps them with the region proposals by MCG, and then runs them through a neural network in order to generate the intelligence that it is a chair. So I'm on the image on the right side, you can see an input raw image on which MCG proposals are overlapped, and each rectangular box is processed through a CNN convolution neural network, and then all the proposals are overlapped, and then they are processed through an EIT divided, so fully connected softmax layer, and the output which has the highest probability would win, and which should be a dog in this specific case. Coming to the architecture of the image, we used MCG instead of selective search, and the input image is processed with the counters and color depth perception, and then it's sent to a convolution neural network, which tries to extract different kind of features from the single image, which are again overlapped with the MCG proposals. And the overlap proposals of the MCG and the extracted feature map will be combined together in a region of interest pooling layer, which would predict two outputs for our project, which are bounding box predictions and then the object predictions. The object prediction means the actual object, whether it's a dog, a human, or a chair, etc. And then the bounding box predictions are the rectangular coordinates, which are like x1, y1 for the down left, and x2, y2 for the top right corner. Let me go through the process flow that we have here. We have training data, and validation data and testing data as well from the image MS COCO image data set. So initially the training data is fed into the neural network along with the training data images. We also downloaded the MCG proposals and then converted the MCG proposals into a selective search format, because we are using faster RCNN, and faster RCNN is only compatible with selective search, and these two are combined and then fed into the training model. Including using the training data and validation data simultaneously, the training model takes in these two inputs and generates the intelligence using the testing data, and it obtains a result. Once you have the result here, you can just download any image and then feed it to the result, and it would predict the result category of the object along with the bounding box coordinates. So here, some of the interesting results. Here we have an image of a person sitting with a dog. This pattern matcher has the capability of detecting multiple objects in a single image. In this case, it detected this specific object as a person with a probability of 99%, and then this specific object as a dog with 99.2%. So in contrast to single prediction in many neural networks, this has the ability to predict multiple objects in a single image, thanks to the MCG proposals that we discussed earlier. There are a couple of other interesting observations as well, in which I've noted here as misleading predictions. So in this specific case, we have a cat and a dog sitting over on a couch, but however the computer can recognize the cat with 90.8% probability, and then the other object on the left as a cat as well with 80% probability. So although the probability is lower, it's it's an error, the probability is very low, which signifies that there could be an error in the prediction. So on the right side, so sometimes this could be seen as a con, and sometimes this could be seen as a pro, for which we have an example on the right hand. So on the right hand we have a T-Rex, which is a canine with 4 limbs and huge nose, so which are like familiar features for a dog, and so that's the reason why the computer predicted this as a dog with 80% probability. So again, the probability is low, which signifies that this could be a incorrect prediction. So let's get the code running, and so that we can see more outputs. So we have the demo code here. See, we have 3 images as of now. Person dog person and person dog and T-Rex. So person dog person is this specific image in which you have 2 persons standing beside a dog, and then we have another person dog .jpg, which a person is sitting next to a dog, and then we have a T-Rex which is an actual T-Rex image. So the idea is to make the computer predict these 2 persons, and then the dog, and then the T-Rex as well. So let's just to give you a perspective on the code. We have coco.py, which is the MS Microsoft Coco challenge code in order to load the data set and to create the annotations, etc., and to write the JSON. And we have one more Coco eval, which basically uses all the other 3 modules, which is written by me, and to output the result into JSON format. We also have Coco Evolve, which is basically generating the JSON annotations that we need here in order to compute the IOU and average recall, etc. These are the IIT categories that we discussed earlier. So let's get the code running so that we can have some actual results in order to discuss. So right now I'm in the pattern matcher directory, and I am my code is in demo.py. So there are 2 modes to run this code. One is with only CPU mode, and then the GPU mode as well. So here I am just using CPU because we are doing a very simple task, and detection we'd only need CPU for less than 3-4 images. So yeah, we can see some sort of processing that's going on here. Like all these layers are part of the neural network that we have here. Yeah, let's see the neural network while the system processes this data. So this is the architecture of the neural network that we have here. We have a convolution neural network that has like 12 number of layers here. Um, uh, this is just a brief outer line of the how the image flows through the network. So at the end we have fully connected softmax layers which result into two branches predicting the bounding box predictions and then the image category predictions. Image category predictions are into EIT categories and then the bounding box predictions are into EIT into 4, which are 324 categories. So these are the predictions that we have here. We have a, let me sort this out. Yeah, cool. So we have in this image we have two persons. Persons are detected with 99.9% probability and 99.5% probability. I'm not sure if the numbers are legible, but I can read it out for you. And the dog is dog detections with a probability of 0.8, and then the dog is detected with 99.2% probability, and then of course the T-Rex is misrepresented as a dog here, but the probability is very less, which is 95.1% probability, which is very less compared to all other which are about 99 point something percentage. And again we have one more percent here, 99.0 percentage. So yeah, this concludes the demonstration of the pattern matcher algorithm. Thanks for your time. Hope you have a great day. Thank you. Bye bye.